This is a video lesson for Module 5, Lesson 9. The Lesson 9 learning target is I can use the area model and division to show the equivalence of two fractions. So today's lesson is going to look a lot like yesterday's lesson, Lesson 7 and 8, except for today we're going to be showing equivalence using the opposite operation of division. So let's go ahead and jump into it and start our first problem. So the first problem I'm going to be looking at is finding the equivalent fractions for the fraction that's being represented in this area model. So hopefully by looking at this area model at this point, you can quickly tell that this is representing 6/12. So when we use division to try and find an equivalent fraction, what we're looking for is to see if we can group the shaded and non-shaded sections into similar size groups. So at this point you might have seen, well, hey, that kind of looks like 1/2 because I can group these 6 that are shaded and these 6 that are not shaded. And that's exactly what we're doing. We're just looking to see if we can group them into bigger groups. So what we've done here is we've shown that 6/12, if we group them into the shaded and non-shaded, is also equal to 1/2. And we show this with division by dividing both the numerator and the denominator by the same number. In this case, that is 6. We're dividing it by 6 because if we look over at our area model again, we've found that we can put 1, 2, 3, 4, 5, 6 equal parts into each group. So that's why we're dividing by 6. And so we find that 6 divided by 6 equals 1, and 12 divided by 6 equals 2. And so therefore we have found and proven that 6/12 is equal to or equivalent to 1/2 using an area model and using division. So let's take a look at another problem here. So in this problem here, we're going to be finding an equivalent fraction for the fraction that's represented in this area model. Now once again, you should be able to tell already that this area model is representing 2/8 because there are 2 parts shaded in and 8 parts total in the area model. So just like in problem 1, we're looking to see if we can group the shaded and non-shaded parts into equal sections. So if I'm looking at this here, at this area model, I can kind of see that I compare these two together, and I can make groups of 2 out of the shaded and non-shaded regions. So because I can make groups of 2, to show this with division, what I'm going to do is I'm going to show that I can take 2, and since I'm making groups of 2, I'm going to divide 2 by 2, and then 8 divided by 2, and I'm going to get 1/4, because 2 divided by 2 is 1, and 8 divided by 2 is 4. And you can kind of see how if we have these 4 equal sections right here, that one of them now is shaded. So we're going to take a look at one more area model and see if we can find an equivalent fraction using division. So let's take a look here. And you might notice something right off the bat similar about this second area model than the first. But first let's figure out which fraction we're going to be finding the equivalent fraction for. So we have 1, 2, 3 parts shaded in, and there are 12 parts total, so we're looking at the fraction of 3/12. And once again, we're looking to see if we can find groups of similar size between the shaded and non-shaded regions, and it looks like I can put 3 together. Groups of 3. And since I was able to put 3 equal parts into each group, I know that I'm going to be dividing the numerator and the denominator by 3. So I'll have 3 divided by 3 over 12 divided by 3. And 3 divided by 3, of course, is 1. And 12 divided by 3 is 4. So you can see that I get the same fraction as I got in the first area model, 1/4. So since we were able to find that both of these fractions are equal to 1/4, we could say that 2/8 is equal to 3/12, which is equal to 1/4. So all 3 of these fractions are all equivalent. So that should be all you need to answer all the questions in the Lesson 9 problem set. But if you get stuck on any of the problems, you can always come back and rewatch the video to make sure that you understand how to find equivalent fractions using area models and division.